In this video, I want to again talk about another example where I have a hypergeometric distribution, but I'm going to use the binomial distribution to approximate that. The difference between this video and the previous video is now we have a between probability instead of an at least probability. Otherwise, these are pretty similar type of example. Okay. So here we have a survey of 13,000 Americans. 60% said that they did not support a new income tax. If 15% of the surveyed Americans were randomly selected for a follow-up question, find the probability that more than 6 but fewer than 10 do not support the new income tax. Okay, so we have 15 being selected from the 1,300. You either support or you do not support the income tax, and that is why this is a hypergeometric distribution. Okay, so small n, our sample size is 15. It's coming from, these 15 are being selected from those 13,000. Okay, and that selection is happening without replacement. Okay, and K, I guess, are the number of people in the population that do not support the income tax would be 60% of this 1,300. But here we could just pause and notice we're not going to use the hypergeometric distribution here because 15 out of 1,300 that's very small, right? If I were to take 15 divided by 1,300, I would get something that's less than 0.05. So the binomial approximation is good to go for this scenario. Okay, so the fact that we surveyed without replacement from the population of 1,300, without replacement had very little impact on our probability. All right. So we're going to use a binomial approximation. Binomial, we need n and we need p. Okay, so p here is 0.6. 60% stated that they do not support the income tax. All right, and so now what we're trying to figure out is the probability that more than 6, so x will be the number of people that support the income tax. Okay, so the probability that x is more than 6, the probability that more than 6 but fewer than 10 support the new income tax. So this is the probability I'm trying to figure out. All right, so I could, more than 6, I could just figure this out by doing, saying, okay, well, this would be the probability that x, well, let me go ahead and write this out. So x could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? 0 people out of the 15 selected could support the income tax. 1 person could support it out of the 15 selected. All the way up to 15 out of 15 support the income tax. We're trying to figure out the probability that more than 6, so 7, and less than 10, 7 to 9, right? We're trying to figure out the probability that x equals 7. Add that to the probability x equals 8. Add that to the probability x equals 9, right? And you could use the binomial distribution. Was it n? Choose x, p to the x, q to the n minus x. You could use this and calculate it for x equals 7, x equals 8, x equals 9. Add them together, okay? You could definitely do that. That takes a little bit more time than just using the table. So we want to talk about using the continuous distribution table or the CDF table for the binomial. All right, so remember the binomial table is going to tell us probability less than, right? CDFs tell less than probabilities. So let's rewrite this. The probability that x is between 6 and 10, this is the same thing as the probability that x is less than 10 minus the probability that x is less than or equal to 6. All right, so that means this between probability is probability x is less than 10, and if I subtract off less than or equal to 6. Makes sense, right? That would just leave me with 7, 8, 9 again, right? This is a less than or equal to is a CDF, right? We could look this up in the table. Now this less than, strictly less than, this is not something, remember the CDF is going to have less than or equal to. So I need to change this, and only for discrete random variables can I do this. Since this is discrete, this is the same thing as less than or equal to 9. Less than 10 is the same thing as less than or equal to 9 because they're discrete, right? So less than 10, strictly less than 10 is the same thing as less than or equal to 9. All right? In continuous random variables, you cannot do this. Only for discrete random variables can you do this. These two things are the same. All right, great. So this is the CDF evaluated at 9 and minus the CDF evaluated at 6. So now I can get my table and look for where P equals 0.6, N is 15. So I'm going to look up 9, 0.5968, and then look up 6, 0.0950. All right, so let's go ahead and write this down. 0.5968 minus 0.0950. Subtract these two, and you get 0.5018. All right, so the probability that more than 6 but fewer than 10 of the 15 randomly selected Americans do not support the new income tax is 0.5018.